Okay, time is 12:30. Let's get started here. Hold on a second. Okay. So, assignment number 2 is due on Friday at noon. Since our last class, I spent some time putting together a good draft of the test. If you notice, the test is or the midterm is coming up on October 6th. Now that I have a good draft of it, what we'll do is at 1:20 today we will spend some time talking about it so you have a better idea of what to expect. Today we will talk about things called macros in SAS. Are there any questions? Okay. So, macros. So, macro functions, that's the more formal name, I will often just call it macros for short, provide a certain level of functionality in SAS that do not already exist with respect to using a data step or a proc. And macros can be very, very useful because of that. There are two different kinds of macros that are available. Please note in the back, we are in class now. You do need to leave. So there are two different kinds of macro functions out there. There are predefined and user-written ones. Predefined macros are macro functions that SAS has already written for you that allows you to do various things. Then there are macro functions that you can write yourself. So user-created macro functions. There are two main purposes of having a user-created macro function. One, it really can help automate some of the stuff that you do, especially things that you want to repeat over and over again that are very similar but maybe differ based upon a few aspects. You'll see some examples of that today. Also, macro functions allow you to, let's say, program into SAS a new statistical method that you have developed. So let's say you are doing research and you come up with some great new statistical method out there and you want to make it available to others to easily use it. Well, you can write your own macro function or functions to do that. A classic example of that is, I think all of you now have experience with proc-limits. Does that sound, or most of you who are taking 821 have experience with proc-limits. Well, before there was a proc, there was a macro called glimix, and that was used for a number of years, and then SAS incorporated all that stuff into a proc. Okay? So let's first begin by talking about these predefined macro functions. A macro function has a name to it, and at the very beginning of the name you will always see a percent sign. So whenever you have a percent sign, that means you're dealing something with macros. The most basic predefined macro function is the %let function. Simply, it allows you to create a constant, let's say, that you can use then throughout your program. So, for example, let me go over here to SAS. So I'm going to use the macro function here to create what's called a macro variable. And I'm just going to call it new title. This is a very simple example just to get us going here. This new macro, or this function, is going to create a new macro variable called new title. And this new title is a constant. Throughout my program, wherever I see new title, SAS is going to treat it instead as my title. Okay? Also, I'm going to create another macro variable using let. It's going to be called x1, and wherever SAS sees x1 in my program, it's going to treat it as the word year. Okay. Now, to put these two macro variables that we've just created to use, I have some simple code here. If you remember from last time, we took a look at this data step that would find the current day and time. Suppose we run that, and then we want to print it off using proc print. Okay, so Let me go ahead and run this part right there. And now I want to print it. For my first line in the results viewer, I want whatever the macro variable new title has in it. Now, to refer to that macro variable, I can't just call it new title. I have to actually call it ampersand new title. So whenever you refer to a macro variable, you always have to start off with an ampersand. And so now the way that SAS is going to interpret it is, oh, I have a macro variable. So that means I'm going to put in my title into where I see ampersand new title. So if I do that, you can see indeed it worked. Okay. Now I apologize if I didn't put this in the notes, but I do want to show you this. So when I was reviewing my notes, I don't remember seeing this. Let's say if I just use single quotes. I know some of you have done that on an assignment before. Let's see what happens instead of using those double quotes. You just see the macro variable name. Okay, so that's the difference between using single quotes and double quotes. I think I even maybe put that on some of your assignments. I said, okay, once we get to talking about macros, there is a difference between using single quotes and double quotes, and this is the difference here. In the end, it's kind of a minor thing, but obviously it can be very frustrating if you don't know about it at times when you're trying to decode what's going on. Well, let's look at another proc print here. Now, I'm going to just print off one variable. Remember, x1 has year in it. So if I say ampersand x1, SAS is going to interpret this as the variable year. So let's go ahead and print that. And there we go. So very simple. Any questions? Okay. More complex situations, for example, occur when you have, let's say, a whole bunch of constants that you need to set in a particular program. So I talk about this on page 2. Here's a program that I created in my research. And basically what this allowed people to do was implement my statistical method that I had just developed. And you can see I have lots of comments there to help people out. And eventually, once I get to the main part of the program, you will see a whole bunch of %lets. So for example, %let tall equal 0.00001. What I used that for in my program was I had to do some numerical iterative method that needed to converge, and my convergence criteria was I needed the difference between successive values at let's say iteration 10 versus iteration 11 to be less than that tolerance value in order to say yes, I have converged. So the nice thing about setting the value out here in my program is that a user can easily change it to whatever they want. Rather than trying to go into my thousands of lines of SAS code that I've written to actually implement the statistical method and figure out, okay, where is that tolerance value? Where do I set it? And so you can see, for example, that alpha. Well, I'm going to do some confidence intervals. Okay, I can set alpha out there. And wherever I say ampersand alpha in my program, it's going to be interpreted as 0.05. Okay. Then page 3 in the notes. Another very simple predefined macro function is put. And put puts information not into the results viewer, but into the log window. In other words, it's going to write information into the log window. So let's say I create a macro variable called x2. It's going to be set to a value of 1. I'm going to put x2 then into my log window. So you can see right there, ignore that symbology and stuff. I'll explain what that is later. So now you can see the value 1 is actually printed to my log window. You can do a whole bunch of stuff. what do you think is going to happen? Don't look at my notes. What do you think is going to happen if I do %let x3 equal 1 plus ampersand x2? What's going to be put in the log window? 2? Nope. What's that?
Don't you need to put it there for that to show?
Well, I'm sorry. Thank you. Suppose I highlighted this code first. So this was supposed to be a trick question to get all of you interested in this lecture. Sorry to give you a trick question, but if I put what x3 is, instead of 2 as you might expect, it's actually 1 plus 1 is actually put there. You have to actually say, oh, evaluate it. Do the math. And then it will actually put 2. But you got to be careful with the eval function, because eval function only works with integers. So if I try to do a plus 0.1 there, I'm going to get a syntax error. And instead, if I want to allow for decimals, I can use sysevalf to do the math. I think this is just a characteristic of an older programming language. I know, for example, older versions of Python had that same quirk to it, that what we take for granted now, of course, 1 plus 0.1 is 1.1. Computer, figure that out. Computers didn't necessarily always figure it out, because it's a different actually form of a numerical value. So if I execute that and take a look at my log window, you can see how I had that error there. You can see when I do use sysevalf, I get 2.1. Okay. Okay. Bottom page 3. Okay, well, let me first say, well, where is the put function useful? So you might be thinking, oh, good, you can write to your log window. Isn't that great? Well, it is useful. It's useful in particular situations where you need to debug a program. Very often when you're debugging a program, I'm sure you've encountered this in other programming languages where you might put like print statements to let you know, oh yes, I've reached this part of my program, or I've reached this part of my program, or oh, this is what the value is at this part of my program. That's where the put function can be very useful, because you can put that information in the log window to try to debug what's going on that is wrong with your program. Another simple predefined macro function is the include function. This will allow you to actually include SAS program code that's in another file in your current program. So for example, if I were to run this segment of code right here, this will run my serial.SAS program that we looked at the first or second day of class. But I'm not necessarily, I don't have that SAS program open here, but by including it, it actually dumps all that information in there. Now, where can this be useful? Well, in situations where you have a long SAS program that has maybe distinct parts to it. You can break that SAS program up into separate SAS programs and then have one overall master program, or you can say a control program that immediately calls in that corresponding code there. This could be a very nice way to write code in an efficient manner. As an example, we go back to this program that I mentioned earlier from my own research. Notice that towards the top of the program, I call in 3 other programs that I've written to do the actual calculations, and they are distinct in terms of they do a lot of different things. So that's why they are different programs. Okay. Any questions? Yes.
So, like when you include a program, so like if you're running, so is it like taking the results to the main program, or just?
It's as if that exact same code was in the program that you have the include statement in. So it will run it just like normal. And you'll see everything in the log window just like normal. Okay, let's talk about user-created macro functions. Here's the general syntax to use. So you say %macro to say, hey, SAS, I'm writing my own macro function here, and I'm going to call it myfunc. I could call it a different name. I just chose myfunc because it's really simple. And then inside of parentheses, you can put macro variable names. So very similar to other programming languages, when you can write your own, let's say, procedures, functions, or routines, where you can pass information into those procedures or functions or routines. That's what a macro function like this allows you to do. So if I were to use this as an actual macro function, I would have to actually pass into my func actual values for var1 and var2. If that's not fully clear, we will have an example showing it coming up. In the end, it's quite simple. So var1 and var2 are going to be macro variables that only work with inside this macro. I end my macro with mn for macro end, and I give the actual name. And then inside the macro itself, I can put code, regular code. I don't need the less than sign and the greater than sign there. This is where you put data steps. This is where you put procs or anything else that you want to include inside of there. So this is the very basic syntax. Now to actually then run my macro function, I say %myfunc. I give a particular value for that var1, comma, a value for that var2. So let's take a look at two examples that illustrate that. So this is a macro function that I have used a lot in my life. It allows me to find the current day and time. Okay, well, we just talked about that. Remember with that data step. And I have found it to be very useful whenever I have like a long-running program, especially in my research, that I print to the results viewer, what time is it right now? What time did the program end? That way, that will allow me to plan for future runnings, for example, of how long do I need to how much time do I need to allocate to letting the program run, for example. It can be very useful too. Let's say if you are doing a Monte Carlo simulation, and it's going to take a long time to finish. Maybe well, you just know it's going to take a long time to finish. And you have to repeat this process 1,000 times in this Monte Carlo simulation. Well, what's a way to figure out then how long it's going to take before actually running it for 1,000 times? Well, run it for, let's say, 5 times. Okay? At the very beginning, run this little macro function I have here to find out what time it is. And then at the end, after those 5, run this little macro function, see what time it is, figure out how long it took. So let's say it took 10 minutes for 5 runnings. Well, then you can extrapolate to, well, how long would it take for 1,000 from that information? So let's take a look at this macro function. So again, macro, I decided to call it time for the lack of a better name. I'm going to pass in one particular value, and the macro variable inside this function is going to be called title. And then similar to the code that we just saw, I have a data step that finds out, well, what day and time is it right now? And then I'm going to do a proc print to actually print the information from that data set. And notice I'm going to put a nice little title that I have passed into it. So when I then, well, of course I end the macro, and then when I run this sometime in my program, I say %time, this part of my program ended at particular time. Obviously, I could change that title to something else if I wanted to, depending upon the circumstances. Okay. Take a look at his second example then. I'll go over to SAS for this one. And this is using the serial data set again, so let me make sure it's all ready to go. I think it is. At least it was ready to go before class. Okay. So this is a great example showing how you can automate certain things that you want to do in SAS to make your life easier. So if you remember with the serial data, we had three, you could say, nutritional variables. We had sodium, salt, and sugar. And, you know, we probably like to summarize all three of those variables in much the same manner. Like, for example, through a plot. How about we do dot plots for each of those variables? So in the end, I want three different plots. And then rather than writing out the code for proc sgplot 3 different times, I can write the code out once and stick it inside of macro. So this is how I do it. So %macro dot plot. I'm going to pass in one bit of information. var1 is going to be the actual macro variable name. And this is simply going to be sugar, fat, or sodium when I run this. Then, for my title 2 statement, dot plot for, put what variable that we're running. Proc sgplot. And this is similar to the code that we've seen before. Remember, we have to actually use a scatter plot to actually get the nice little dot plot. X-axis is going to be shelf. The y-axis is going to be that information I'm passing in, that variable name. Notice how I'm able to change the y-axis title nicely, depending upon which variable that I'm using. And so let me go ahead and get that into SAS. And then if I run it, I'm going to run it with sugar, I'm going to run it with fat, I'm going to run it with sodium. So in the end, we should have 3 plots if everything works out. And indeed, we do. Okay? So that really quickly got us going. Just give you a little bit of a story here about macros and doing functions like this. So the first time that I ever encountered macro functions wasn't actually in any of my coursework when I was a student. In fact, in my courses, we never, ever talked about macros. Where I encountered it was in my internships. They were using macros all the time in the multiple places I had internships. Why? Because it makes life easier, such as this. So my very first time that I actually ever did a macro function was through a plot, where I had to do multiple plots that were very similar, but they had some small differences, and a macro allowed me to do it in a very efficient manner. Now, to build on this story, so then when I always got back from these internships, knowledge such as how to do macros in SAS really gave me, you could say, a leg up in comparison to other students. And I was able to do a lot more stuff in my coursework then, where I did then incorporate the stuff that I learned from my internships, such as macros, I incorporated it into my coursework. And I still remember the day that after my first summer internship, my first fall back, a professor gave us an extra credit project. And I was the one who was able to finish the extra credit project because I was able to do everything nicely with the help of macros. So because of that experience, I always, whenever I've taught SAS in all my classes, I always try to introduce macros. Okay, let's see now. Let's talk about some options that are available to us with using macros in terms of, if you remember, in SAS, towards the very top, that option statement, that allowed us to do some stuff such as, the line size equals 64, how many characters are on each line. there's a variety of different options in SAS. Most are not useful for our purposes. But when you are using macros, here are 3 options that I always include in all my programs. This is very, very helpful for diagnosing problems that might be occurring with your code. So let me go over here back to my program, or I'm sorry, my notes. Hold on. Okay. So, typically, go back up. Typically, when maybe some code is not working well, typically, we go into the log window, see if we can figure out, okay, what's going on? Well, why isn't this working? And a problem with using macros in SAS without the additional option statements I just talked about is that the log window is not necessarily very descriptive about what's going on inside a macro when that is actually running. So without those option statements, and if I were to run that same set of code that I just did, this is what it looks like in the log window. You have some information that, okay, this was after running the dot plot with sugar. We have information, okay, procedure sgplot is running. Oh, I did something with a, and it said how many observations were being used. But notice it doesn't say necessarily, well, what did this particular value, and this is SAS's terminology, what did this particular value resolve to? Resolve, R-E-S-O-L-V-E. What's the value of var1? And also, if you can imagine, let's say, having a whole bunch of other procedures and data sets in there, it gets kind of messy in terms of the information that SAS is going to give you in that log window. It can be difficult to figure out exactly what's going on. So if we compare this then to, what happens when I run that same code by first invoking these particular options. What's going to happen is that Imprint option is going to tell you, let me just, I always forget exactly which does which. There we go. Sorry. So the Imprint option traces the SAS statements generated by the macro execution. So it actually will tell you, it will actually print the regular SAS code as it's being run, just like you would normally see if you weren't running macros at all. So say, okay, here is all my data set code that just ran. Here's all my proc code that just ran. Where, if you look back in the notes there, that information wasn't provided to you. It just said, okay, proc sgplot ran. Okay, so Imprint can be a little bit helpful. The one that I think is the most helpful is this symbol gen. That means these macro variables, think of them as symbols. What are those symbols resolving to? So ampersand var1, what is that? Oh, it's sugar. Ampersand var1, the next time it's, oh, it's fact, for example. And then M logic, where M again stands for macro, helps you more, again, trace the flow of what's being executed inside the macro itself. So if we take a look at, then after we run those option statements, here's what the log window now looks like. You can see a lot more information is being printed. And it tells you, okay, this is generated by mlogic, this is generated by symbologen, this is generated by Imprint. Okay? Now there are some duplications. So for example, these two lines basically tell you exactly the same thing. But if you look throughout this log window printed here, they are not exactly the same in terms of what they give you. Sometimes they will duplicate parts. And so I always would then look at this to say, okay, var1 is sugar. Oh, look at this. In my proc sgplot code that's essentially being printed to my log window, I can actually see not ampersand var1 there, but y equals sugar. as that's the way it's actually interpreted as by SAS. Okay. Any questions? Okay, that takes us to page 12. So let's talk about loops and conditional execution. So we've talked about this with respect to data steps already. Inside a data step, you could use a do statement to, let's say, do I equal 1 to 10 and do some stuff. Hold on, I got to write a note to myself. Okay. Also, we talked about like an if-then-else type of statement inside a data step. But there are times where you want to have more flexibility, where you want to be able to do that kind of logic outside of a data step. And so there are some predefined macro functions available to you that allow you to do that. The key is, with these functions, is that you can only use them inside of a user-created macro function. You cannot just use it in normal regular old code. It has to be inside a user-created macro function that you've written. That's the only time that these new macro functions I'm going to talk about, that's the only time they can be used. Very important. I know when I was beginning, I was very frustrated when I couldn't get code to work, but it looks like it should be working, and oh, I forgot the percent do statement has to be inside of a user created macro function. So anyway, let's talk about do loops. The syntax, percent do, then you have a percent to, and then you end the loop with a percent end. So, for example, let's say I wanted to repeat something 10 times. Then percent do I equal 1, percent to 10. Put your code there. That code can be data steps. It can be procs. And then you end it with percent end. Now, one useful thing that SAS does then is that this I here actually becomes a macro variable. So you can actually refer to that I with ampersand I inside any code that you use there. You'll see an example where I do that shortly. Okay. So let's talk about an example. Let's say that I want to create 6 data sets. 6 separate, 6 data sets, each with 1,000 observations. And these observations are coming from a population characterized by a normal distribution with a mean of 0, but different standard deviations. Excuse me. These standard deviations, again, are going to change for each data set. And so let's look at how I can do this. Okay, let's see here. Let me get some stuff out. Okay. So my macro is simply going to be called example 1. I'm not going to pass in any information into it. This is somewhat of a made-up example. So I didn't have anything that I really needed to pass into it, so that's why you don't see parentheses, a variable name, macro variable name. And what I like to be able to do is, with these 6 data sets I'm going to create, I'm going to put them all into one overall SAS data set. So I want to save them after I create them. And a quick way to do this, not necessarily the most efficient, but a quick way to do this is to, first of all, you could say initialize a data set to save them in. So this data set, for lack of a better name, is going to be called save. And since I'm initializing it, I mean I don't have anything in there right now. I'm going to say set underscore null underscore and then run. We've seen that underscore null underscore before. Does anyone remember where?
Because we don't really want to create a data set.
Exactly. So where we've used this before, this was in the Intro to SAS notes, is we wanted to export a data set out of SAS, put it into like a comma delimited file. And so the way that we did that was we did something like data null and we had some code there that didn't look like that, but we had some other code there that we use. Or let me include one more. Set, let's say that the data that we wanted to put in there was set 1. We wanted to put this outside of SAS, so we had like a put statement, we had a file statement. But we really didn't need to create a new data set inside of SAS. All we wanted to do was take some stuff in SAS and take it out. And so we use that null there to say, okay, I don't want to create a new data set. Now here, I'm using the null a little bit of a different way, meaning I'm going to basically, I want to create this new data set, but I'm not going to put anything into it yet. Okay? So, let's create these new data sets. Use a do loop. %do I equal 1, %2, 6. I don't know why I chose 6 data sets, I just did. And then I'm going to take code that we learned about in the previous section of this course to create these data sets. Data, before we always had like set 1 or something like that there. But notice I'm going to say set ampersand I. This is a way to, you can almost say, dynamically create data set names. Because that ampersand I is going to be interpreted as, the first time through the loop, 1. So the first time through the loop, I'm going to create a data set called set 1. Second time through the loop, set 2. And so on. Then, I'm going to use a stream init call routine that we saw previously that allows me to set a seed. Notice how I'm going to change the seed every time, because if I use the same seed, I'll get the same data, or at least the data will be connected to one another. I don't want to do that. And then here's my do loop inside the data step, like what we did before. Do j equal 1 to 1,000. Use the ran function to create the data or simulate the data from a normal distribution. Notice ampersand I there. That's going to allow me to have a different standard deviation. So the first time through, the standard deviation is 1. Second time through, the standard deviation is 2. Last time through will be 6. Then I'm going to create a variable in this data set that matches that I. Just it helps me organize things. Output it and run. And then lastly, I'm going to put all these data sets I'm creating into one overall data set called save. And so data save set, what did I have in there before? And now what's in that new data set that I just created? And so what's going to happen is 6 times through the loop, the first time through, nothing's going to be in save because remember we use null. And it's going to put set 1 in there. Second time in the loop, it's going to have set 1, it's going to put set 2 right below it. Third time through the loop, set 1, set 2, set 3. Hopefully, since I talk with my hands a lot, this is helping you see what's going on. My wife gets scared when I talk with my hands when I'm driving. You can guess why. Anyway, so this is a very common way that I use a lot in my own programming to save stuff when I'm looping over some stuff. I want to save it over and over and over again. Now remember what's happening here. Every time you do this, you are writing over the previous version of save. Remember, you're actually writing a file to your hard drive. Let's say that set 1 didn't have 1,000 observations. Suppose it had 1,000,000. Set 2 has 1,000,000, and so on. So you are continuously writing over that same data set over and over again. Is your computer going to be happy with you? Maybe not, because it's not very efficient. There are more efficient ways to do stuff like this. In my notes, I talk about, I think, proc append and proc data sets. You are not responsible for those, but I do want to mention that they are available. For our purposes in this class, this is a simple, quick, dirty way to do this kind of stuff that I still use. I do use SAS every once in a while, that I still use to do this. Okay. So, macro ends. Let's run it and see what happens. So if I go to my log window, you can see how I have all this information being printed here that really helps me out to see what's going on. So for example, macro variable I resolves to 6. That's the last time through the loop. And if I take a look at my save set, there's the first part of it, and I can page down and eventually get to the second data set that was created. Okay, now that I have this information, let's do some summaries of what's in this saved data set. Let's start by using proc means to find the mean and standard deviation. Now we know what the mean and the standard deviation should be for each of these separate data sets or separate values of I. Let's see if this occurs as we would expect. So proc means, data's in save, I want the mean, I want the standard deviation. Use the class statement to say let's divide this up by I. The variable x, that's where I stored my simulated normal values. And here we go. Remember, the mean should be about 0. In fact, that's what occurs. Standard deviation for each of those i's should match up with what the I is. And you can see, generally speaking, that's what occurs. So just to make sure you understand some basic statistical concepts here, what happens as my sample size increases? What's going to happen to that mean and standard deviation? It's going to get closer to what I set it to be. Exactly. Okay. Now you might be wondering why it looks like, you know, some of these means are getting farther away from 0 as I is increasing. Why is that? Yeah, the standard deviation, because I have more variability in my data. So there's going to be more variability of that sample mean. Central limit theorem. Okay. Well, it's not necessarily central limit theorem, but it's a property that's often said with respect to the central limit theorem. Let's do a plot. Okay. I have 6 different data sets. I want to do 6 different histograms with a normal distribution overlay. One way I could have done it was to create a macro function that would do each of these plots one by one. Alternatively, I actually want to make comparisons between them. So ideally, I like to have all 6 of these histograms in the same graphic sheet, you could say. And so the way that I'm going to do that is use a procedure that hopefully all of you have investigated. It's called proc SG panel. This is not one I went over in class, but I did say during the graphic section, please take a look at that. Here's how we can use it. So proc SG panel. The word panel is there because that's a common term that's used with trellis graphics. If you remember, trellis graphics allow you to put basically multiple plots in the same graphic sheet. Each of those plots are put into what are called panels. So in this case, I'm going to have 6 different panels. So the panel by argument, I. It just says, okay, well, how am I dividing this up? Histogram X, density X. And notice this is the same kind of syntax that we used before with proc sgplot when we were only doing one plot at a time. And so if I run this, you can see those are my 6 histograms. Really quick. So with I equal 1, remember we have a small standard deviation. With I equals 6, we have a large standard deviation, and you can see that that's what happens. We can see how the data is following that normal curve very well, as we would expect. Okay, any questions? Yes?
So the difference between normal do loop and the percent do loop is you can retrieve the I value in the code.
I wouldn't say that's the difference. The difference is the percent do has to be done within a user-created macro function, and it provides a lot more flexibility in that it's done outside of a data step. Inside that percent do, you can include procs, you can include data steps, as many as you want. Where the regular old do loop that we had seen previously was only within inside a data step. Any other questions? Okay. Let me get back over to my notes. We are on page 14. Okay. So I think, this little syntax here is a useful thing to know about macro variables. That you can stick a name next to the actual macro variable itself and create a new name, you could say. Well, what happens if maybe you have, let's say, 2 macro variables that you want to use to dynamically, let's say, create a new name? So let's say I have a macro variable I and macro variable k. The way that you can put them together is you use a period. SAS is not going to put a period in there. It's just a way for SAS to understand I'm separating ampersand I from ampersand j. So let's say I have a nested do loop. One for I, one for k. Both are, let's say, I equal 1 to 10 and k equal 1 to 10. The first time through the loop, I will be 1, k will be 1. And so this name here will be set 1, 1. Okay. Now, as I mentioned at the beginning of this little subsection, is that there are if-then-else statements that can be done as well. I want you to take a look at my program to see how I actually implemented it. Basically, I do the same code that we just got done doing there, but I show, well, let's say if you wanted to do something in a conditional manner. So real briefly, here's the syntax that typically one would want to use. If some kind of condition is true, then do it. So just for like in a data step, when we had an if, then, else, at times when we had more than one thing that we wanted to do, when the condition is satisfied, we say do, put the stuff, and then end. Here, since we're dealing with macros, we have to do percent do, percent end. Notice the else there, percent do, percent end. So one place where I've used the percent f macro before is if I am doing a Monte Carlo simulation, that again I know is going to take a while, and I want to somehow monitor the progress. I will, in my program, use this percent then else, well actually just percent then, you don't have to actually include the else if you don't want to. I use the percent then, percent if, percent then, to print to my log window using the percent put function when I've reached, let's say, iteration 100, or iteration 200, or 300. And that just helps me monitor the progress when something I know will take hours to complete. rather than me just sitting at my computer wondering, I wonder how far along I am. Maybe things aren't working out. Maybe I should just stop the program. Okay. So, again, take a look at my second example. That shows how one could do something like that. Are there any questions? Okay. So there's actually two things I want to talk about next. We'll first talk about the tests. Or midterm, same thing. Okay. So this midterm will be only over the SAS portion of the course. So if you look at the actual schedule, I think the test is October 6th. Just double check. Yep, October 6th. You notice we have some other stuff. We're going to get out of SAS soon here, so that's kind of interesting. That LaTeX stuff is not going to be on the test. It's just going to be over SAS. Overall, for my lecture notes, so you can see how I've kind of divided. Let me actually go over here. Obviously, I divided the SAS portion of the course into subsections. I purposely on this test have put at least one question corresponding to each of those sections. So, don't say, I'm not going to study the graphics section. I'm going to chance it. Don't chance it. Okay? I purposely have tried to grab at least one question corresponding to each of those subsections. The test itself is going to be completely computer-based. So if you by chance have talked to any students who have taken some of my previous courses and asked them about these computer-based tests that I give here, this format's going to be a little bit different than what maybe they told you about. It's going to be completely computer-based. What I mean by that is that you will be using the computers at your desk. SAS is on them. Although SAS isn't working right now on them, I'm working on figuring out what the problem is and getting that fixed. Hopefully it will be by October 6th, otherwise we will have a problem. At 12:30, what I will do is I will say, okay, go to my website. You can download a Word copy of the test. You will need to type in all of your answers into that Word copy of the test. Okay? There will be nothing that you hand in a paper format. You will be handing in the electronic format of what you've typed for your answers. So obviously in those kinds of situations, you want to make sure that you are saving your document. You are backing up the document during the tests. Because, obviously if you accidentally, let's say for some reason, decide to close out your Word file and you forgot to save what was in there, well, you've lost all your answers. So be careful about that. Is again, as I've told you in the past, it's closed book, closed note, but you will have access to all of my SAS programs. And of course, you'll be using SAS on these computers, so you'll have access to the SAS help as well. I may ask you to download a data set to work with on the tests, and so it just would be on my course website. Okay, this is again a draft of the test. There are 3 problems on the test. The first problem, I think it has like 3 parts. Asks you to write some SAS code. Now, am I going to ask you to write 100 lines of code during the class? No. But there's going to be some procs, some data steps that you're going to have to write. The second problem, to save you time, is I'm going to give you the SAS code, or at least most of it. And you're going to need to tell me, what does this part of the code do? What does that part of the code do? And maybe it might be helpful for you to type some of it in and run it. But I'm hoping that, or at least if you have prepared enough, you shouldn't have to do that. And then the last problem of the tests are a number of short answer questions that are not interconnected in any way. So part A and part B, they're not connected in any way. So what you get for part B has no effect on what's for part A. And so here's a potential question that could appear on the test. That would be a short answer question. Let's see. What are 3 ways that one can find out an ODS table name? What are 3 ways that one can find an ODS table name? When we use ODS, we are trying to, let's say, extract information from a proc, and SAS puts all the information from the procs into what it calls tables. And when we want to create a new data set based upon what's in the proc, we need to know that table name. So, can someone name one way?
ODS trace.
ODS trace, but
Turn it on, look in the log window to find.
yeah. So look in the log window with the ODS trace. What's another way?
Can't you have it printed out with your output?
To the output window. So that's the second way. What's the third way?
The library.
Excuse me?
Go to the Explorer in the library.
Go to the Explorer. So I come over here. I didn't emphasize this way as much, but yes, you can come over here and you can figure out. Yeah. There we go. So I just right-clicked over there, and then there's one more way.
Is there any help?
Help. Yeah, exactly. So at least I didn't ask you for all 4. Yes.
Would we need to explain how to do that stuff, or just
That will be enough. I mean, there will be times where I might say, okay, list something out and then explain it. I don't think in that particular case where I would need you to explain.
Okay.
So that's an example of a short answer question. I could give you like a small segment of code and say, okay, tell me what's wrong with it as part of a short answer question. Or I give you a short. Well, yeah, I don't want to give another one away. Let's see. So, I guess with that short answer question, the first short answer question I gave you an example about, to me, example that you've studied enough is if you could just write out the answer without, let's say, looking at any of my old programs to see how I've done it, or without looking up in the help for how to do it. So if you're able to name 3 of those 4, hey, you've studied enough. The reason why I bring that up is because, oftentimes when you're given additional information to you when you're taking a test, you fall into the trap of you don't study enough. Like in the classic open book, completely open book situation, where you spend all your time trying to look through your book or look through your notes trying to find what the answer is. And so, while I do give you the SAS programs, don't rely on them too much. They're there to help you when you need to write some code, and if maybe you can't think of what the answer is immediately, you can look it up. But try your best to try to do this just from your own studying. In the end, I don't want you to have to memorize code, but through practicing the assignments, through going through my notes, you should have a basic idea. Okay, how do I do a plot? Oh, proc SG plot. So I can start podcast gplot. I'm going to need data equals set1. And then, maybe you might remember, oh yeah, it's a scatter statement to do the scatter plot. That's the level of preparation I expect that you will have for the test. If for every single question you're always going back to my programs and you haven't studied enough. Okay, so that gives you a general idea of the test. We will spend some time reviewing for the test, the class period before the test. So, while you're always welcome to ask questions at any time in our class, that will be a time where I say, okay, you have questions, let's do it now. Any questions right now about the test format? Yes.
Are we cut off at 145 or whatever?
You can go to 145 for sure. And now I have looked to see, well, when's the next class that comes in here? And that class doesn't come in here until 2:30. So I am willing to go a little bit longer if needed, especially since this might be the first time that I would imagine most of you have taken a test like this. But make sure or plan on 145. We'll see how things go, and maybe we'll go a little bit longer. Okay? Any other questions about the tests? Okay. Now the second thing that I want to talk about, I forgot to ask this at the beginning of class, and that is I asked all of you at the end of our last class was to figure out how to do a plot of a normal distribution in SAS. Are there any questions about how to do a normal distribution plot in SAS? Now I'm going to ask another question. I'm not for sure exactly how to ask. I could either ask it as how many of you were able to do the plot, or how many of you were not able to do the plot. Which way do you think I should ask?
A lot of hands up or not a lot of hands up?
Oh yeah. Well, the thing is though, even though the question should be, at least I think I worded it this way, one should be the exact opposite of the other. There will be some hands that don't go up at all. Would anybody like to talk about how to do the plot? Okay. Actually, the code's not too difficult. And one reason why I like to do this is because, especially many of you are teaching, and and when oftentimes when you want to talk about like a normal distribution when you're teaching, you just draw it. It's not to scale. But really, doing this stuff yourself to scale and showing your students, okay, this is indeed what the y-axis looks like, is not that difficult. So to do the plot in SAS, unfortunately, at least with respect to the main way that people use SAS, there's not like a nice little proc that says, okay, here's an actual mathematical function I want to draw. Draw it for me. There's not a way to do that. There is in R, but there isn't in SAS. So what you have to do is you have to go back to the old days of when you first learned how to do a plot, where you have stuff on the x-axis and y-axis. And you have on the y-axis, you want your mathematical function to be evaluated, essentially. So what did you do? You plug in a whole bunch of x values into your equation, and you get y values out. So how can we have SAS evaluate a normal density function for a whole bunch of different values that we put into it? A do loop within a data step. So for example, I could do something like this. Data temp do, we're going to do a standard normal here. So I know a standard normal, everything should be between -3 and 3 in terms of the, let's say, the z values. How about we go -4 to 4 just to make sure we got everything covered. So do z equal -4 to 4. Now one thing that I have not talked talk to you about is, well, how can I do this without it going from z equal -4, -3, -2? Suppose I want a finer grid. By, exactly. So by, oh, we'll just do 0.1. Okay. And then what I want to do is calculate, you can say f of z. In other words, the normal density value itself, the height of the normal density curve. So fz equal PDF normal mean 0 standard deviation 1. Then what do I need? I need this stuff to be put into the data set. Output. Thank you. And then I'm done. And let's do run. Let's check the log window. Okay, that's looking good. Let's find the data set. So for example, oops, I didn't do something right. I know what I did. Sorry. Where's my code? There it is. What did I not do right? Sorry. So if you're writing that down, of course you can always watch the video if you don't want to write it down. I forgot the little z there. To say, okay, evaluate the normal density at this z value where I have a mean of 0 and a standard deviation 1. I'm surprised that did I have a syntax error there? I'm surprised it executed it. Okay. Maybe it was thinking there was some defaults. So that, whoops. Why do I always have to close that out? Okay. And there we go. So at f of -4, the height of the normal density curve is 0.0001. Well, we expect that because there's very little probability there. Okay, now I need to do a plot. What proc should I use? SG plot. Data equal temp. Okay, so the other thing that would be new to you, other than that by statement, was what statement do I need to make here to do the plot? If I use scatter, what's going to happen is there's going to be a whole bunch of points on the plot. I want a line. So you might be thinking, oh, there's a line statement. No. I said it began, I think I said last time it began with the letter S. I have a series of points that I want to connect with a line. Series. I think it would have been better to say line, but this is their code, not mine. So the x-axis is going to be z. The y-axis is going to be f of z. If I wanted to, I can make it look real pretty and do various options, but I'm not going to do that. And then if we just do run, and there is my nice little plot. Not too difficult. So obviously, you could do this with other probability density functions. Pick your favorite probability density and do a plot. So it's really nice to have it to scale. It'll be interesting to know, and maybe this will help, especially if you're teaching Stat 218. It will be helpful to these Stat 218 students to actually know that, yes, that y-axis there has an actual numerical value, that you can actually draw this out, that you have this ugly-looking f of z or f of x thing that you're actually mathematically evaluating. You're not going to some statistical tables and you get this magical number that comes out. So, any questions? Okay, then that is it for today.